There is a nice way to write large numbers.
You can write the number 1000 as a 10 to the power of 3, meaning that is a 1 followed by 3 zeros. Or you can write the number 1,000,000, that is a 10 to the power of 6, meaning that is a 1 followed by 6 zeros.
There is no largest number. If anybody gives you a candidate, you can always add the number 1 to it. But there certainly are very big numbers. The American mathematician Edward Kastner once asked his nephew to invent a name for an extremely large number.
10 to the power 100, which I can't write down all the zeros in this page because there isn't enough space. The boy called it a Googol.
If you think a Googol is large, consider a Googol Plex. That is a 10 to the power of Googol. That is a 1 to the power of not 100, but by a Googol zeros. Now, by comparison with these enormous numbers, the total number of atoms in this book is about 10 to the 26. Tiny compared to a Googol, and of course much less compared to a Googol Plex. The total number of elementary particles, protons, neutrons, and electrons in the accessible universe is in the order of 10 to the power 80. That is a 1 followed by 80 zeros. That is much less than a Googol and vastly less than a Googol Plex. And yet these numbers, the Googol Plex, do not approach. They come nowhere near infinity. In fact, a Googol Plex is precisely as far from infinity as is the number 1. We started to write down a Googol Plex, but it wasn't easy.
Writing down a Googol Plex is a spectacularly futile exercise. A piece of paper large enough to contain all the zeros in the Googol Plex couldn't be stuffed in the known universe. Fortunately, there's a much simpler and concise way to write a Googol Plex, like this.